This is the second lab for computer architecture. We are using MobaX again, and we are in the Nano lab2.asm. So for this lab, the key points are using scanInt to get user integer input and storing that to later add and subtract it and then output the result. So the first thing I'm going to do is put the title of the lab, my name, and then how we are going to assemble, link, and execute our program all in comments at the beginning. To assemble this, we're going to do AS for assemble dash O, and then we're going to do lab.2.o, and then we're going to do lab2.asm. This will assemble it. After this, we need to link it to my professor's library, which is csc35.o. So we're going to link that, which is LD, and then we're going to use a.out to run it, and then lab2.o and csc35.o. Lastly, we're going to execute it in the main part when we're going to use ./a.out. So now we can start writing our code. To begin this, we need to state what format we're using, and we are using the .intel syntax with no prefix. We are going to first write our .data section, and this is where we are going to have all of our. So first we're going to be in our .data section, which contains all of our methods or all of our titles that we are going to be calling later in our program. First, we are going to have the title of what we're doing, and this is going to be Harry Potter based. So we'll have our title, and we need the colon like this, and we have spacing, and then we're going to do .ascii, and then we need our string. So we will have our parentheses, /n, and /0. /n for a new line, and then /0 to end it. We want another spacing in here, so we're going to have to do another /n. That way we get 2 lines of space between this, our title, and the rest of our prompts. So we're going to have Gringotts Wizarding Bank. And after this, we want to basically have 2 prompts that ask the user for their income, and then 2 more prompts that ask the user how much they spend. And then we are going to store their responses and then use this later to have addition, subtraction, and output the result. First thing that we're going to do is have our first earnings. So we'll do earn 0, and this is our title, and in here we'll have .ascii, which will give the prompt, and we will say how much do you earn from work. Then we're going to need a /n for a new line, and then /0 to end this line. So after we have this earn 0, which prompts the user for the income, we are going to store their value. We're going to do this later in our code, but we need a placeholder to store it. So what we can do is call this value 0, and this is where we're going to store the response. We'll say .quad is 0, since we're going to store it like this, and then we're going to do the same and prompt the user for another source of income a second time. So we've made our second earning value where we're asking how much we earn from work, but we can change this into a different prompt. So instead of how much do you earn from work, we can just say how much do you earn from gifts. And then we are going to have a value which will be our storage location for the user input. Now we need to ask how much they are spending, and it's going to be basically all of this, but just how much they are spending, and then we're going to make values below it as placeholders or storage for when we later need to store our values in here. So I changed this should be quad 0, not quad 1, and then I wrote spending 0 and asked how much do you spend on rent, and then I store this in our value 2, which is .quad 0 again, and then prompt the user for the next spending, which is how much do you spend on food and medicine, and then we're storing this in value 3 using .quad with 0. So now we have this, we can write out another .data title for spacing, and we can also do one that types out the income and the expenses and cash flow. So I did another title with space here and did a .ascii /n/0, and all this is doing is having a space here. So if we call it, it's just going to print out a line, getting a new line. And this is for spacing out any of these parts, or if any of these parts up here need additional spacing. And we are going to print out the income and the expenses and the overall cash flow. So that's why we have all of these. And now we can get into the dot text section. So after we have all of this, we can go below here and do a dot text. And then after we have dot text, we can do dot global space start space underscore start on our new line, and then do underscore start. And now we can start writing or calling all of our program. So first we want to print out our title. We're going to do LEA, which is load effective address, racks title. And what this is doing is it's going to call title, load it into racks, and then print it out using the call C or print C string. After we print out the title, we want to first prompt the user and then store their input. So we're going to say LEA, which is load effective address, RAX, and we're going to print out earn 0. And then we are printing this out using the call print C string from the professor's library. And then after this, we are going to call scan int, and then we are going to store this value. So in here we'll do call scan int, and then below this we are going to move the value that we get into our value 0. So we're going to do move, and then we're going to store it in val 0. So we're going to write this as val 0, comma RAX. So we are storing the scanned int into RAX and then moving it to value 0. And then after we do this, we want to print out a space. So we'll do LEA RAX space, and then we are just going to call the print C string. We are then going to do this for the second part of the income, and then move on to the spending, and then print this out. So I wrote out the second part for the second part of our income. We're loading the effective address of the earn1 into RAX, and then we are printing it out using the call print C string, and then we are calling scan int to get the user input. We are storing the user input in RAX and then moving it to val 0. This should actually be val 1 because we don't want to overwrite val 0. So we're going to change this to val 1, and then we're going to store that in there. Next, we are going to print out a space, loading our space call into RAX and then printing out using it print C string. After this, we are going to do the same thing but for where we spend. So we are going to load the effective address of our spend 0 into RAX and then print it out using call print C string. Then we want to see how much the user has spent, so we're going to do a call scan int. We are going to then move this value into val 2. That's RAX, we're using RAX. And then we are just going to print a space, a new line. So we're going to do LEA, load effective address, RAX, space, and then call the print C string to print it out. We're going to do the same exact thing for the next spending value. Next, we are going to print out the income. We wrote earlier that we are just having the your income is, so we're going to print out the total income. So that means we have to add the income or the earn 0 and the earn 1 together and then print that out. First, we're going to print out what we wrote earlier, and that's going to be Leia RAX income, and then we're going to print this out using the call print C string. And then after this, we are going to do our math. So first we're going to move our value 0, which is our first income, into RAX. So this value right here, we are going to move it back into RAX. So we're going to have RAX, which is where we're moving it into, and then val 0. So val 0 is going to move into RAX. And then after we do this, we are going to add it to val 1, since val 1 is our next earn. So we are going to have add, and we're going to add RAX val 1. So now RAX holds the value of 0 plus value 1. Value 0 is moved into RAX, so now RAX is equal to val 0. Now val 1 is being added to RAX, so RAX now stores val 1 plus val 0. We're going to have to store this in another value because we are going to use RAX again. So what we can do is say move into RBX, RAX. So now RAX is being moved into RBX, and then we are just going to print out a space. So we're going to do load effective address, RAX space, and then call the print C string to execute it. Next, we are going to deal with the spending, or how much the expenditure is. Now we want to print out the total. We want to print out the cash flow. So we're going to have load effective address, RAX, we wrote it as cash, and we're going to do this by using the call print C string. And instead of adding here, now we have to subtract our values. So we are going to move into RAX val, or not value, we're going to move RBX because RBX is our income. So we're moving RBX into RAX. Now what we're going to do is subtract. So we'll have a sub, and we're going to subtract with RAX and RCX because RCX is our expenses while RBX is our income. So we're subtracting our expenses from our income. Next, all we're going to do is call print int to print this out. In fact, with our income and our expenses, we want to print these out as well and not just do math in it, because when we call these right here, when we do LEA, which is load effective address, into income, our income is this string right here, your income is, and then we don't have a new line, so it's going to be on the same line, so we have to print out the actual income. So in our income right here, before we have our space, we are going to do print int, but we have to call this, so it's actually going to be call print int, and then we're just going to print RBX since it's the last thing we have here. And then same thing for expenses, where before we have our space, we are just going to do a call print int, and this will print out RCX since it's the last thing we have here. And then we will have another space right here just to separate the cash flow from our expenses, and we're just going to have a LEA RAX space and just do a call of print C string. After this, I'm just going to print out another string and then end the program. After this, we're going to control X to save it and click yes, enter, and then we are back here. Clear this, and now we are going to assemble the program to see if it works. So we're going to do as-o lab2.o, and then we're going to have lab2.asm, press enter. We don't have any errors so far, so that's good. We're going to do ld for linkdat -o lab2.o. Before this, we should have a.out and then csc35.o to link this to the professor's library. Press enter. We have no errors, so this looks good. We're going to do ./a.out to run it. Press enter, and we have our prompt. So we have our title. How much do we earn from work? We'll put in 3. How much do we earn from gifts? We'll put in 3 as well. How much do we spend on rent? We'll put 2. And then we should have a space here, so this will be on the next line, but we'll just have 2 like this. And we can see that our income is $6, so this is correct because it's adding our first 2 incomes. Then it's going to add our 2 expenses, which is 4, and subtract these 2. So our cash flow is 2. So this is correct. We just have to put another space in here. So I'm going to go into the code by doing nano lab2.asm, and now we are back in our code. So it seems like in this second spending right here, I should have a /n as well as a /0 to end this line. After I have this, I am going to just exit and save. Now we're going to go back into the code so we can look over it real quick. First thing, all of these lines is just talking about our code, it's introducing our code. This line right here, the .intel syntax no prefix is just stating which syntax we are using. And then we are going to be in our .data section, and this is where we're writing out all of our prompts and where we are storing things. So first we have our title, which prints out our title. We are prompting how much do we earn from work, and then we are going to later store this value into val0. We've made a container for it. We're going to do the same thing for earn1, val1, spend 0, val2, spend 1, val3. We also make a space for extra spacing just to keep things neat when we need to. We have a line stating the income, we have a line stating our expenses, and then a line stating our cash flow. So then we go into our .text, we use .globo start, and then we have our start. So first we are loading the effective address of title into RAX and then printing out this string. Then we are taking our earn0 and printing it out here, and then we are calling scanInt to get the user input, and then we are going to store the scanned int into val0 so that we can use it later, and then just print out a space. We're going to do this for earn0, spend1, and spend2, or spend0 and spend1 as well, and then we are going to do our calculation. For income and expenses, it's basically the same thing. So we are getting our val0, which is where we first stored our first income, and then we are storing it into RAX. So we are getting the value 0, which is our first income, storing it into RAX, and then we are adding val1 to RAX. Now RAX has val0 and val1, and then we are moving this value into RBX and storing it there so that we can keep it and use it for later. Then we are calling the printInt, which will just print the last thing we have, which is RBX. So we are going to print out RBX. Then we're going to have a space. Then we're going to do the same exact thing for expenses. After we do this, we have cash right here where we are printing out our cash flow. And then we are calling printCstring to just print this out. And then we are going to move RBX, which is our income, into RAX. Then we use sub to subtract our RAX from RCX, which is our expenses. Then we are just going to print this out using the call printInt, and then print out a space, and then end the program. So if we exit this, and then just test it by running it one more time, and assemble it, link it, and then we can run it. So we have our title and our first prompt, how much do we earn from work? We'll say 5. How much do we earn for gifts? We say 5. We spend 1 on rent, 1 on food and medicine. So our income is 10, expenses is 2, and our cash flow is 8. And that is the end of this second lab.